Welcome to Science for Sleep, where wonder and calm meet. Each night we drift through galaxies, oceans, and mysteries of the natural world, not to startle, but to soothe. Unveiling cosmic dust, the building blocks of worlds. 101 Sleepy Facts for Wonder, the universe's tiny architects. What if I told you that the ground beneath your feet was once dust floating in the deep, silent darkness between the stars? Not the kind of dust that settles on bookshelves or drifts in sunbeams, but particles so small, so ancient, and so delicate that they formed long before the Earth existed. What if I told you that the air you breathe, the oceans that shimmer beneath sunlight, the mountains that rise from the crust, and even the atoms in your body began as cosmic dust? Dust scattered through what appears, at first glance, to be empty space. Dust suspended patiently in the quiet of the universe, waiting for gravity, time, and gentle motion to shape it into something more, something structured, something living, something aware. If you were to look into the vast distances between stars, it may seem like nothing is there, a great silent void. Darkness stretching in every direction, endless and unchanging. But that is only the view from far away. If we drift closer, quietly and slowly, the darkness begins to soften. The blackness takes on a subtle grain, and then, as our view shifts to microscopic scales, tiny specks of solid matter begin to appear. These are particles of cosmic dust, small fragments of silicates, carbon compounds, ice crystals, metal grains, and organic molecules. They are not debris. They are not leftovers. They are the raw material from which stars and planets form. Cosmic dust is astonishingly small. A single grain may be a few micrometers across, smaller than what the human eye can resolve. And yet, though each particle is tiny, the universe contains unimaginable quantities of them. Dust drifts through the space between stars, carried on interstellar winds. Dust accumulates in enormous clouds, regions of space called nebulae. Dust swirls in the disks around young stars, slowly gathering into pebbles, into stones, into worlds. This dust is the starting point of planetary systems. Without cosmic dust, there would be no planets, no moons, no oceans, no chemistry of life. Without dust, the universe would contain stars alone, brilliant, beautiful, but lifeless. The remarkable thing about dust is that it is not originally made in space. It is made inside stars. Every piece of dust was once part of a star's atmosphere, its core, or the remnants of its death. When massive stars end their lives in supernova explosions, they cast newly formed elements into space. These elements cool, condense, and crystallize into tiny grains of solid matter. Smaller stars produce dust more slowly, gently shedding their outer layers as they age. Over millions of years, these grains drift outward, spreading into the galaxy. The dust travels far, across light years, across regions of quiet, into clouds where other stars are waiting to form. Dust carries memory, the pattern of nuclear reactions that occurred inside the star that made it. Imagine a grain of dust drifting for millions of years. It does not rush. There is no wind pushing it, no urgency guiding its path. It floats in the interstellar medium, moving slowly, carried only by gentle currents of gas or the faint pull of gravity. It may pass near young stars, through regions of intense radiation, across shock waves from distant supernovae. It may be heated and cooled many times. It may pick up atoms from its surroundings, forming thin layers of ice in the cold. molecules arranged in delicate lattices. It may become coated with carbon compounds as it travels through denser regions. Dust is both traveler and seed. It absorbs the environment around it and carries that history into whatever it becomes a part of. Eventually, these grains of dust begin to gather in clouds called stellar nurseries. To the eye, these nurseries appear as glowing nebulae, vast regions of gas and dust illuminated by nearby stars. But those glowing colors are only one layer. Beneath the light lies a deeper structure, cold, dense pockets of dust and gas where gravity begins to take hold. Gravity is patient. It does not act suddenly or sharply. It gathers. It encourages closeness. Dust grains drift closer to one another, slowly drawn inward by their combined mass. The cloud thickens. Shadows grow darker. Temperature falls. The center becomes denser. And then, at last, as the pressure increases, something extraordinary begins. A star is born. The formation of a star does not happen with an explosion or a flare. It begins in silence. The dust and gas collapse inward, forming a spinning sphere, small at first, no brighter than a deep ember. Over time, hydrogen atoms within the sphere begin to fuse, releasing energy. The sphere brightens. The core heats. Light is born from gravitational collapse and nuclear ignition. A new star begins to shine. But the dust does not disappear when the star forms. Instead, it gathers into a disk that surrounds the young star. A thin, flat shape, whirling gently, stable and wide. This disk is the cradle of planets. Inside it, dust grains collide, not with violence, but with slow, soft contact. Each collision allows a grain to stick to another. Dust becomes clusters. Clusters become particles. Particles become pebbles. Pebbles become stones. This transformation happens slowly, so slowly that even the concept of time feels stretched. Millions of years pass, and the stones continue to grow. Eventually, some of them become large enough for gravity to take over. They pull nearby material toward them. They become planetesimals, small, irregular worlds, quiet and cold. These planetesimals collide, merge, and reshape one another, gradually forming protoplanets. And here, in this long, slow, gentle process, we see something profound. Worlds grow from dust. Everything we know, oceans, forests, mountains, clouds, animals, and people, began as dust drifting through interstellar space. Dust that held no structure, no life, no awareness. Dust that simply existed, quietly, patiently, waiting to be gathered into something new. When we say that we are made of stardust, it is not a poetic exaggeration. It is a literal truth. The atoms in your bones, your blood, your eyes, your thoughts, each one originated inside a star. Each one traveled through space. Each one participated in the story of cosmic formation. The universe did not create life separately from itself. Life is a continuation of the universe's structure, a further unfolding of its patterns, a new form for ancient matter. And so, when we gaze at nebulae glowing in the night sky, we are looking not only at clouds of dust, but at the beginnings of future worlds. Planets that do not yet exist, oceans that have not yet formed, life that is not yet awakened, entire histories that are waiting to unfold. Dust is tiny. Dust is unassuming. Dust is quiet. But dust is where everything begins. The stellar nurseries, If we continue drifting through the quiet of space, past the scattered stars and into regions where the sky begins to appear hazy and luminous, we will find ourselves entering a stellar nursery. These are vast, cold clouds of gas and dust, stretching across light years, held together not by structure or boundaries, but simply by gravity and the delicate balance of pressure within the cloud. To the naked eye, they appear faint or invisible. But when illuminated by nearby stars, they glow with soft reds, purples, and blues, shaped by the wavelengths of light absorbed and re-emitted by the dust within them. Stellar nurseries are not static. They are dynamic regions full of slow, persistent motion. Dust swirls through the gas like mist drifting through air. Temperature varies subtly. Some regions cool to just a few degrees above absolute zero, while others warm slightly under the influence of starlight filtering through their outer layers. In these temperature gradients, dust grains begin to shift, cluster, and drift. Gravity quietly encourages these small gatherings. Over millions of years, they move closer together, pulled inward as mass collects in certain areas. There is no rush. There is no sudden transformation. The nursery does not hurry to create stars. It allows the process to unfold naturally, slowly, gently, as if time itself were in no hurry at all. As we move deeper into the cloud, the soft glow around us begins to fade. The dust becomes thicker. Light struggles to penetrate the density. Shadows deepen, not because the cloud lacks material, but because it holds too much. In these dark zones, light from outside cannot pass. We are now inside one of the quietest regions of the universe, the cold molecular core of the nebula. The silence here is not like the silence of Earth. It is complete, without breeze, without vibration, without sound. A silence so immense that even thought feels softened. This is where stars begin. Gravity draws the dust inward. Even the smallest variations in density cause the cloud to collapse, pulling matter toward its center. As material gathers, the core becomes denser and warmer. Hydrogen atoms, the simplest and most abundant elements in the universe, begin to cluster in unbelievable numbers. Though everything remains delicate and slow, the mass continues to grow. The center compresses and pressure increases. Deep within the core, where no light can escape, a new object begins to take shape, a protostar. A protostar is not yet a star in the full sense. It does not shine with the balanced, continuous glow of hydrogen fusion. It is a warm, contracting sphere, glowing faintly from the heat of compression. It is like a dim ember at the center of a cold and dark cloud. If we could observe it closely, we would see that its surface is not solid, but a layer of hot gas shaped by the forces of gravity and internal heat. Around it, a disk of dust and gas begins to form, extending tens to hundreds of astronomical units out into space. This disk is the foundation from which planets will eventually emerge. The disk forms because everything in the universe rotates. Even the enormous cloud of gas and dust that collapses into a star has some initial spin, no matter how small. As the cloud contracts, conservation of angular momentum forces that spin to increase, causing the material to flatten into a wooden, thin disk. At the center of this rotating structure, the protostar continues to gather mass. The disk around it holds the remaining material, the raw matter from which worlds are sculpted. The dust in the disk is not uniform. Some particles are silicate grains. Some are carbon-rich compounds. Some are ice crystals made of frozen water, methane, or ammonia. Some contain iron or nickel. Many particles are combinations of these components, layered and shaped by their long journey through the interstellar medium. These dust grains, though tiny, carry the memory of ancient stars that lived and died long before this new star was born. If we were to pause now and simply observe, we would see something astonishing. The dust in the disk is in constant motion. It circles the young star in silent orbits, drifting slightly inward or outward as it interacts with gas flows and temperature changes. Dust grains occasionally touch, not violently, not forcefully, just lightly. A gentle adhesive force, known as the van der Waals attraction, allows them to stick. At first, the adhesion is fragile, easily broken. But over time, repeated collisions allow the grains to grow into clusters. The clusters become larger, forming tiny, irregular shapes, microscopic stones floating in a vast river of gas and light. This process is called accretion, and it is the beginning of all planets. Accretion is slow. Dust does not transform quickly. It requires time, stillness, and patience. In the quiet of the disk, particles that have drifted for millions of years through the galaxy now find themselves gathering into new structures. Pebbles form. Pebbles become boulders. Boulders collide and merge into objects large enough to exert gravitational pull. These are called planetesimals. They range from a few kilometers to hundreds of kilometers in diameter. Their surfaces may be rough, irregular, or cratered. They glide silently through the disk, tracing gentle paths around the star. Some of these planetesimals continue to grow. They gather material. They reshape their own surfaces through gentle impacts. Eventually, as they become more massive, gravity shapes them into spheres. These are the earliest forms of protoplanets, young worlds forming in the cradle of dust and gas. Inside the nursery, multiple protoplanets may form at once, orbiting the young star in a slow dance. Some survive, some collide and merge. Others are flung outward into interstellar space, becoming lone wanderers between the stars. The formation of worlds is a quiet, intricate, elegant process, shaped by chance and guided by gravity, heat, and time. Throughout this entire scene, the stars are still forming, not just one, but many. Nebulae often give birth to clusters of stars, large and small, bright and faint. Some become massive blue stars that burn brightly and die quickly. Others are red dwarfs, faint and cool, glowing gently for trillions of years. The diversity of stars emerges from variations in mass, density, rotation, and environment. Each star has its own story. Each star may have its own system of planets. And surrounding every one of these stars is dust. Dust that remembers. Dust that continues to transform. As we drift slowly through this nursery, watching stars ignite and planets form, we begin to understand something subtle and profound. The universe does not rush to create. It allows, it invites, it unfolds. The birth of stars and worlds is not an event, but a process, gentle, gradual, and deeply patient. And all of it begins with dust. From dust grains to planetary seeds. If we remain here, drifting near the young star and the wide disk of dust that surrounds it, we will notice that something almost invisible is happening everywhere at once. The dust grains, so small that a single one could sit unnoticed on the tip of a human eyelash, are beginning to gather into new forms. This gathering is not sudden. It is not directed by intention or design. It is simply the result of motion, time, and gentle forces acting together. The particles move within the gas of the disk, carried by currents that are too delicate to feel and too subtle to see. And every so often they touch. In a warm environment like this, dust grains cling to one another by extremely weak forces. Electrostatic attraction, molecular interactions, and tiny adhesive bonds. A single collision means almost nothing. But collisions happen again and again and again. Grain meets grain. Grain meets cluster. Cluster meets cluster. The smallest forms of structure begin to appear. They are the first fragile steps in the formation of a world. This stage of planetary formation is called accretion. It is quiet, slow, and patient. Nothing about it seems dramatic. There is no moment of transformation, no visible change that feels sudden. It is more like the slow accumulation of snowfall on a resting field. Layer upon layer, small addition by small addition, until something new begins to take shape. The dust grains in the disk are not identical. Some are made of silicates, minerals that will one day form the rocky crusts of terrestrial planets. Some are composed of iron and nickel, metals that will sink deep into planetary cores. Others are clusters of carbon compounds, fragile and dark, capable of forming complex organic molecules. And further from the star, where the temperature of the disk falls below the freezing point of water, dust grains become coated with frost. Ice forms a thin crystalline shell around them, making them sticky and more likely to clump together. This region is known as the Snowline, a boundary that plays a profound role in shaping the architecture of planetary systems. Inside the Snowline, where temperatures are warmer, planets tend to become rocky. Their surfaces harden. Their atmospheres remain thin. These are worlds like Earth, Venus, and Mars. Outside the Snowline, where ice remains solid, worlds have access to far more material. The particles are stickier and more abundant. Protoplanets here can grow faster and larger, eventually forming the giant planets, Jupiter, Saturn, and others like them, in distant star systems. But right now, we are still at the earliest stage. The dust grains are only beginning to form pebbles. They are small, irregular shapes, barely visible, almost weightless, floating through the disk. Yet each one contains the memory of everything that came before it. Every element they hold was formed inside stars that lived and died long ago. Every atom once belonged to something greater that existed before the world being born here. As we continue to drift, we can see that the disk is not uniform. There are regions where dust is gathered more densely, regions where gas flows form spirals, regions where turbulence stirs like a gentle whisper. These variations are important. They create pressure traps, places where dust collects rather than disperses. Within these traps, dust grains gather faster. Pebbles become stones. Stones become boulders. Over thousands of years, these larger bodies begin to shape their surroundings. A boulder drifting through the disk is not passive. It has mass, and mass exerts a tiny gravitational pull. At first, the effect is minimal, but as the boulder grows, the pull becomes stronger. Dust and smaller stones respond. They drift inward, drawn slowly toward the boulder. With each new addition, the boulder becomes more massive, and the pull becomes stronger still. Eventually, we arrive at the first truly new object in the system, a planetesimal. A planetesimal is small by planetary standards, perhaps only a few kilometers wide. but in the scale of dust and gas, it is enormous. It is large enough to have gravity that reshapes its surroundings. It is large enough to survive collisions without being broken apart completely. It is large enough to begin clearing a path through the disk. In the quiet darkness of the disk, planetesimals drift like seeds of worlds. Some are solitary, content to move gently along their orbital paths. Others encounter one another. These encounters are not soft. They occur at speeds that allow stone to fracture, shatter, or fuse. Sometimes two planetesimals collide and merge, forming an object twice as large. Sometimes one fractures into many pieces that will later reassemble. The process is complex, chaotic, yet directed by the simple and persistent rule of gravity, drawing matter to matter. As time continues to pass, millions of years, slow and unnoticed on the scale of human life, some planetesimals grow into bodies hundreds or thousands of kilometers across. Their gravity becomes strong enough to draw material in from afar. They become protoplanets, young worlds that are not yet finished, not yet fully formed, but undeniably planets in their own right. These early worlds are warm. Heat comes from the energy of countless impacts. Heat comes from radioactive elements within their interior. Heat comes from the pressure of self-gravitation. Their surfaces are molten or partially molten, glowing faintly beneath a thick and hazy atmosphere of gas and dust. They are not yet stable. They are still being shaped, molded by forces that have worked patiently since the dawn of time. The disk around the star is now a place of structure. There are gaps where protoplanets have cleared space. There are rings where dust continues to circle undisturbed. There are currents of gas flowing inward toward the star and outward toward the outer edges of the system. The disk will not last forever. It is a temporary feature. In time, the gas will dissipate, evaporating into space under the influence of starlight and stellar wind. The dust will be absorbed into the planets that survive. But for now, the system remains in quiet motion, cradled in the warm glow of a star still young enough to burn softly. If we step back slowly and calmly, widening our view until the entire system is visible at once, we see something familiar emerging. The arrangement of orbits, the spacing of worlds, the structure of rings and belts. It is faint, still taking shape, but unmistakable. A new planetary system is being born, and all of it arose from dust. Dust that drifted alone through the darkness. Dust that gathered in the quiet body of a nebula. Dust that formed the seeds of worlds. The universe builds patiently. The universe builds gently. The universe builds through dust. The Snowline and the birth of boundaries. As the young star continues to glow at the center of its disk, warmth radiates outward. Close to the star, temperatures are high. Here, ice cannot survive. Water, methane, and carbon dioxide remain in the gas phase, drifting freely among the dust grains. But farther out, where light weakens and heat diminishes, the temperature drops low enough for these molecules to freeze and cling to the dust, forming tiny crystals of ice. This invisible threshold, defined not by distance alone, but by the balance of heat and cold, is known as the Snowline. The Snowline is not a wall and not even a boundary in the physical sense. It is a gradient, a transition zone where solid and vapor phases of key compounds shift due to temperature. Yet this gentle variation shapes the fate of entire solar systems. Inside the Snowline, planets tend to be built from sturdier, rock-forming materials. Outside it, worlds grow from both rock and ice. And ice, being abundant and sticky, allows bodies to grow larger and faster. If we look at the planets in our own solar system, we can see this pattern clearly. The inner worlds, Mercury, Venus, Earth, Mars, are rocky. They are compact, with thin or absent atmospheres, shaped by heat and mineral chemistry. Beyond the Snowline lie Jupiter and Saturn, massive gas giants built around cores that grew rapidly thanks to the availability of icy grains. Farther still are Uranus and Neptune, worlds of frozen water, methane, and ammonia, cloaked in deep, cold atmospheres. But this pattern begins long before planets look like planets. It begins in the disk, where dust and ice grow into pebbles and then into planetesimals. Outside the Snowline, the addition of ice makes grains more adhesive, accelerating growth. Pebbles form rapidly. Clumps grow larger. And soon, in the cold outer regions of the disk, worlds in waiting swell with mass. Inside the Snowline, growth is slower. Collisions are more delicate, and the available solid material is limited. Yet even here, planets form, patiently, steadily, without haste. Each region of the disk creates worlds that reflect the conditions of their birth. But the path from dust to planet is not smooth. It is shaped by tension, by gentle order, and by quiet disruption. Between the forming worlds, there are regions where material is left behind. Places where planetesimals formed but never gathered into a planet. These regions are the asteroid belts, quiet archives of creation. They are not debris fields in the chaotic sense. They are the remnants of worlds that could have formed but did not, either because the timing was delicate or because gravitational influences prevented their assembly. Imagine a small world beginning to grow between two forming giants. It gathers dust, it gathers stone, it begins to shape a path of its own. But nearby, a planet much larger is forming, a gas giant with a growing gravitational presence. Its pull is gentle but persistent, a tug that subtly alters orbits. The smaller world is drawn into resonances, cycles where its orbit and the giant's orbit interact. These subtle influences can prevent growth, disrupt collisions, or scatter material. The small world remains unfinished, not destroyed, not erased, but never allowed to fully become. This is how asteroid belts arise. They are the quiet, unfinished chapters of planetary formation. In our solar system, the asteroid belt between Mars and Jupiter tells this story clearly. Mars was able to form, small and rocky. But in the region beyond it, Jupiter's presence was too strong. The dust and stone there could not coalesce into a planet. Instead, it remained a collection of fragments, each holding the chemical memory of the early solar system. These fragments are not failures. They are records. They carry the original compositions of the disk. They hold frozen water, minerals, organic compounds, the same materials that formed planets and oceans, and eventually, life. When asteroids strike worlds like Earth, they bring not only stone but ingredients, carbon chains, amino acids, molecular structures that are precursors to biology. Farther out, beyond the gas giants, lies another belt, the Kuiper Belt, where icy bodies circle in quiet darkness. These objects are older than any mountain on Earth. They are as ancient as the solar system itself. They formed when the sun was young, when the planets were still glowing spheres of molten stone. They have remained largely unchanged. To look at them is to look backward in time, In the space between worlds, belts and rings are not emptiness. They are archives, places where the history of formation remains preserved. The Snowline helps define where these regions form. It shapes the architecture of planetary systems, just as gently as a shoreline shapes the meeting of land and sea. If we step back again, widening our view, we see that planetary systems are not accidental. They are the result of structure emerging from subtle differences. Differences in temperature, density, gravity, and time. Dust becomes worlds not by force, but by coherence. By the simple truth that matter attracts matter. By the quiet persistence of gravity. The universe does not sculpt planets with violence. It does not rush their formation. It allows everything to unfold slowly. Worlds are not assembled in moments, but across epochs. Their surfaces cool, their atmospheres settle. Their oceans, if they form, take shape drop by drop. And through all of this, from the tiniest grain to the first shining world, one element remains constant. Everything begins with dust. When worlds begin to change, as we drift farther along the timeline of planetary formation, the protoplanets that once glowed with internal heat begin to change. The furious impacts that shaped them become less frequent. Their surfaces, once oceans of molten rock, slowly cool. Heat escapes into space, radiating outward in waves that gradually fade into the cosmic background. What was once liquid stone begins to harden, forming the first crusts. Thin, fragile, constantly broken by the last of the incoming fragments still falling from the disk. The air around these worlds at this stage is thick and hazy, a mixture of gases released from the molten interior. Water vapor, carbon dioxide, ammonia, methane. Substances that drift upward from a planet's molten heart and rise into the cooling sky. There is no clear horizon here, no blue sky, no oceans yet. Just a silent, heavy atmosphere that wraps the world like a veil. Everything is raw. Everything is new. Everything is becoming. This stage may last millions of years. Planetary formation is not quick. It is not dramatic in the way storms or eruptions are. It is slow transformation. It is heat fading. It is crust thickening. It is the world learning how to hold its own shape. Some planets at this time remain quiet and small. Some grow enormous. Some pull in the light gases around them, hydrogen and helium, and become giants. Others are too small to hold such gases and remain rocky, with dense surfaces and thinner skies. The diversity of worlds appears early and naturally, not from chance alone, but from the subtle physics of distance, gravity, heat, and time. On certain worlds, something remarkable begins to happen. As the surface cools and the atmosphere stabilizes, water vapor condenses. Clouds form, not the gentle clouds of Earth, but vast global blankets of mist and storm. The rain begins, not in isolated showers, but in continuous, planet-wide rainfall, falling for thousands or even millions of years. What was once vapor becomes liquid. What once drifted becomes gathered. The oceans are born. These first oceans may be shallow or deep, calm or tumultuous. They reflect the chemistry of the dust from which the world formed. If the dust contained minerals that dissolve easily, the oceans become rich with metals and salts. If the dust carried carbon compounds and nitrogen, the oceans become reservoirs of molecules that may someday interact, combine, and evolve. The universe does not create life suddenly. The universe creates conditions, environments where chemistry can stretch, explore, and gradually shift into complexity. On Earth, the water that formed the oceans came partly from volcanic outgassing, and partly from the dust and icy planetesimals that helped build the planet. Some of the water may have arrived later, carried by comets or asteroids. Ancient travelers from the cold outer regions, bearing liquid potential frozen into crystal form. When these objects struck the young Earth, they delivered more than stone. They delivered memory. They delivered possibility. The dust that once floated through nebulae now rests as waves. The atoms that once drifted in silence are now carried in tides. The ocean surface becomes a mirror for the forming sky. And slowly, as minerals dissolve and currents move across the world, chemical shapes begin to appear. Simple molecules bond. Patterns form. Reactions repeat. The earliest hints of biological structure emerge. Not yet life, but the potential for life. Not yet consciousness, but the seeds from which consciousness will grow. Many worlds may reach this stage. Some worlds cool enough for oceans to form, but too quickly freeze solid again. Some worlds become too hot, their oceans boiling away, leaving barren ground beneath a thick and suffocating atmosphere. Some worlds never gather enough water to make oceans at all. But some, a small, precious fraction, remain warm enough, stable enough, and quiet enough for the slow dance of chemistry to continue uninterrupted. Those are the worlds where time can work its deepest transformations. If we step back, if we widen our view once more to the scale of the system, we see an entire orchestra of planets, moons, asteroids, and comets orbiting a single star. Some worlds are barren, some are icy, some are gaseous and immense, and perhaps one, maybe two, are settling into the gentle conditions needed for oceans to breathe and molecules to unfold. All of it, every moon, every stone, every drop of water, every molecule that carries the potential for life, began as dust. The same dust that traveled through the nebula, gathered into disks, collided softly into clusters, and grew into planets. The universe did not need to rush. It did not need to interfere. It allowed matter to simply be and to become. Life, when it emerges, does not appear as something separate from the cosmos. It is the cosmos, continuing itself in a new form, and so a world cools. The sky clears, the oceans settle, the dust rests at last, not gone, but transformed. Water, organics, and the seeds of life. As the young planet settles into its new state, the crust cooling and the oceans spreading into basins and valleys, something subtle and profoundly important begins to unfold. The waters that now cover parts of the planet carry more than simple molecules. Dissolved within them are the organic remnants of stars. Carbon chains, nitrogen clusters, and fragile molecular structures that once drifted freely through interstellar space. These are the seeds of chemistry, not yet alive, not yet organized, but capable of becoming something more. The dust that formed this world was not chemically empty. It contained the products of ancient stars, atoms forged in stellar cores and supernova blasts. Atoms reshaped in the cold quiet of nebula, atoms that had already formed molecules long before planets existed. In the darkness between stars, cosmic rays, ultraviolet light, and the cold vacuum encouraged these molecules to combine into complex organics. Simple sugars, amino acids, carbon rings, precursors to the materials that form living cells. When this dust became part of a forming planet, it did not lose what it carried. The memory of its cosmic journey remained, encoded not in stories or symbols, but in structure. And now, in the warmth of the young planet's oceans, these molecules drift and encounter one another, pulled by currents, stirred gently by tides, warmed by geothermal heat rising from below. There is no spark of sudden life here, no dramatic moment of emergence. Instead, there is simply time. Time for molecules to meet. Time for patterns to form. Time for reactions to repeat. The ocean becomes a quiet laboratory, vast and ancient, where chemistry is given the freedom to explore itself. In some shallow pools, minerals crystallize into surfaces that guide molecular assembly. In deeper regions, hydrothermal vents release heat and elements that encourage complex interactions. The ocean floor becomes a vast, silent stage on which the shapes of future biology begin their slow performance. If we look closely enough, not with eyes, but with imagination, we can almost see the first steps toward life unfolding. Chains of molecules linked together. Some structures become stable enough to last for moments before dissolving. Others remain long enough to interact with new molecules. Patterns appear, simple repetition, copies made with small imperfections, the slightest spark of self-perpetuation. Not life, but the hint of a direction. None of this is rushed. None of it is forced. The universe does not demand life. It simply allows for it, in places where conditions remain gentle long enough for complexity to deepen. Not every world reaches this stage. Some planets cool too far and freeze. Their oceans lock beneath thick shells of ice, and their chemistry falls into stillness. Some worlds dry out, their water evaporated or lost to space, their surfaces left scorched and silent. Some planets are too restless. Volcanic upheaval, bombardment, and storms never allow their oceans to remain stable. Life requires patience. It requires stability. It requires quiet time. On worlds where these conditions persist, something remarkable is possible. Not inevitable, just possible. The dust that once drifted freely through space gathers into oceans and stones and minerals that support the formation of self-organizing systems. Some of these systems endure, some expand, some learn to persist in changing environments. And over millions or even hundreds of millions of years, molecules that once drifted alone now form networks, structures, and cycles that echo the patterns of the universe itself. And if we observe this slowly, with care, we begin to see the subtle continuity. The universe does not simply produce matter. It produces processes. Processes that transform. Processes that unfold. Processes that deepen complexity. Dust becomes stone. Stone becomes world. World becomes ocean. Ocean becomes chemistry. Chemistry becomes something that can remember, something that can adapt, something that can change, something that can live. Even before life begins, the planet holds the quiet potential of it. The first organic molecules drifting in the sea are echoes of the same bonds that once formed inside distant stars. The universe is not separate from life. Life is the continuation of the universe in a new form, a form capable of awareness, capable of reflection, capable of looking back on the path it took and whispering softly, "I came from the stars." And so, here in the quiet waters of a young world, the story of dust continues. Not finished, not paused, simply unfolding into a new chapter, one shaped by time, persistence, and the soft, patient rhythms of the universe. Life may not appear quickly, it may not appear at all. But the conditions are here, the stage is prepared, the ocean is calm, the chemistry is ready. And time continues to move, slow, quiet, unhurried. The quiet architecture of planetary systems. Imagine now that we slowly rise away from the young planet, drifting upward through its soft atmosphere, past the clouds that gather in gentle, swirling currents. The surface grows distant. The curvature of the planet becomes visible, a quiet sphere wrapped in ocean and stone. Higher still, the star's light begins to sharpen, no longer diffused by water vapor and haze. And then, at last, we slip beyond the boundary of the sky and into the open space of the planetary system. Here, there is silence again, not the silence of emptiness, but the silence of distance, of vastness, of the slow and steady dance of celestial bodies. We can now see the entire system at once. The star at the center, young and bright. The planets in their orbits. The trace of dust and gas that still lingers. The rings and belts that mark the paths of what has yet to become, or what will forever remain only the memory of formation. The planets move with extraordinary grace. Their orbits are not hurried. Each world follows a path determined by mass, distance, and the quiet pull of gravity. The most patient sculptor the universe has ever known. There is no sound of motion here, though everything is moving. Worlds circle their star. Moons circle their worlds. Dust and ice continue to drift. Comets sleep in distant reservoirs, waiting for the gentle nudge of gravity that will guide them inward someday. Nothing in this system is truly still, yet nothing is rushed. Planets settle into orbits that feel natural, as though the universe has found a balance point and allowed it to rest. Some worlds orbit close to the star, warm and bright. Others circle far away, cold and slow, their years stretching into spans beyond human comprehension. The architecture of the system reflects the early stages of dust and accretion, the quiet songs of gravity that began long before planets took their forms. In time, the leftover gas is swept away. The star emits wind, streams of charged particles that flow outward into space, thinning the remaining cloud of the nebula. The disk that once held the ingredients of planets becomes clear. The system opens into space, no longer hidden within a cocoon of dust and gas. What remains is a finished arrangement, like the last strokes of a painting whose composition is now complete. A rocky planet here, a gas giant there, a belt of asteroids marking the echo of a world that almost formed. A collection of frozen bodies circling at the system's edge, holding ancient ice like a memory. This arrangement, though stable, is not rigid. Over millions and billions of years, worlds continue to influence one another. Gravitational pulls pass across space like subtle whispers. Resonances form, harmonizing orbits into repeating rhythms. Some planets migrate inward or outward, changing their distance from the star. The system is alive in a slow cosmic way, not with biology, but with motion. The architecture of a planetary system is a conversation, a gentle negotiation, a balancing of pull and release. And the story that began with dust has now become an entire celestial family. Star planets, moons, belts, clouds, comets. A system that is complete, but never finished. Stable, but always in motion. If we drift farther outward still, the star grows smaller, until it is once again only one point of light among countless others. The planetary system we have followed, so detailed and vast, becomes only one of billions spread through the galaxy. Each one is different. Each one carries its own story of formation, its own unique paths, shapes, distances, temperatures. And yet, all of them began the same way, with dust drifting through interstellar clouds, waiting for time and gravity to draw it together. The universe repeats this pattern not out of monotony, but out of elegance. It knows how to build worlds from the simplest ingredients. It allows complexity to emerge from quiet beginnings. And in this architecture, this arrangement of orbits and distances, the conditions for life may exist, not everywhere, not often, but somewhere, among the billions of stars and trillions of worlds, oceans reflect light. Somewhere, molecules learn to remember. Somewhere, dust becomes aware. Everything continues in silence. Nothing is hurried. The universe unfolds itself, patiently, in patterns older than memory. The silent influence of giant worlds. As we look across the planetary system now settled into its quiet orbits, one feature becomes impossible to ignore. Some worlds are small, rocky, and calm, circling close to the star, where warmth is steady and light is abundant. But farther out, in the colder reaches of space, where sunlight arrives faintly and the shadows of distance deepen, there are planets of a vastly different scale. The giant worlds. They are enormous compared to the rocky planets near the star. Worlds of gas and cloud, worlds without solid surfaces, worlds whose atmospheres stretch thousands of kilometers deep. Their colors shift in soft bands. Their storms curl in slow, majestic spirals. And their magnetic fields reach far into space, shaping the paths of charged particles and guiding the invisible architecture of the system. Yet for all their presence, these giants move with quiet dignity. They do not rush. They do not flare or burst. They simply continue their orbits, unbothered and unhurried. To understand the formation of habitable worlds, it is essential to recognize the role these giants play, a role that is subtle, gentle, and deeply influential. Though they may exist in the outer regions, far from the warmth of the star, their gravity reaches inward, shaping the orbits of smaller bodies, protecting some, disrupting others, and determining the stability of worlds that may one day hold oceans and life. In our own solar system, Jupiter is such a guardian. Its immense mass pulls asteroids and comets into stable orbits or flings them outward, away from the inner worlds. Without Jupiter, the inner planets, including Earth, would be bombarded far more frequently by large objects. The calm periods required for oceans to settle and biology to unfold might never have arrived. But Jupiter is not simply a protector. It is also a shaper. In the early era of planet formation, when dust and gas still swirled around the young sun, Jupiter's mass carved paths into the disk. It shepherded material. It set boundaries. Its gravity prevented planets from forming in the region we now call the asteroid belt, leaving that space as a quiet archive of the system's beginnings. A giant planet is not merely a passenger of the solar system. It is a sculptor. In other planetary systems across the galaxy, we see similar patterns. Wherever a massive planet orbits, smaller worlds respond to its presence. Some are nudged into stable configurations, locked into rhythms where their orbits resonate in harmony, repeating the same celestial pattern over and over. Others are moved inward or outward, migrating across the disk, seeking regions of equilibrium. It is a slow influence, a patient guidance, barely noticeable across the span of a human life, but unmistakable across millions of years. Sometimes, a giant world drifts inward, moving close to its star, a hot Jupiter. When this happens, it can disrupt everything in its path, scattering rocky planets, scattering water-rich worlds, leaving behind a system with a large world near the star and little else. In such places, calm worlds like Earth may never form. Oceans may never gather. Dust may never learn to remember itself as life. Other times, the giants remain in distant, circular orbits, offering stability. They act as quiet guardians, clearing debris, reducing chaos, allowing time and stillness to accumulate, the conditions life requires most. When we step back and look again at the planetary system as a whole, we see that it is not randomness that shapes these worlds, but balance. A balance of gravity, heat, time, and distance. A balance that emerges naturally, without guidance, simply from the laws that govern matter itself. The dust that once floated everywhere has now become arranged. It has taken on form and purpose without intent or direction, simply because matter gathers, time unfolds, and gravity binds. The rocky planets circle close to the star, small and warm. The giant planets maintain their steady vigil in the cold beyond. And far out, at the edges of the system, frozen worlds drift through the quiet, carrying memories older than the planets themselves. Life, if it will come, can only arise in a system with room to breathe. A system where collisions have slowed, where oceans have time to settle, where surface conditions can stabilize enough for chemistry to deepen into something that lasts. The giant worlds provide that room. They do not create life. They simply make space for life to have a chance. Their influence is silent, invisible, but profound. They are the great, slow guardians of the cosmic story, shaping worlds without touching them, whispering gravity across the darkness, allowing dust to become planet, and planet to one day become aware. The hidden oceans of distant moons now. Let us drift outward again, past the rocky planets and past the great giants that guard the system's harmony. Beyond them lies a region where sunlight weakens into a pale glow. Here, temperatures fall, surfaces freeze, and worlds appear at first to be silent and lifeless. Yet appearances in the universe are often deceiving. Beneath the icy shells of certain moons, something remarkable waits. Entire oceans, hidden from the light of the sun. These moons are small compared to their planets, but they are full of quiet potential. Their surfaces are hard and white, reflecting what little light reaches them. They appear frozen all the way through, solid ice, unmoving. And yet beneath these shells, warmth persists. The warmth does not come from sunlight or from surface heat. It comes from within. Moons orbit giant planets, and in doing so, they are stretched and compressed by gravity in a slow, rhythmic motion. This gentle but constant flexing produces heat deep inside their cores, heat that melts ice from below, forming oceans that are sealed beneath the surface. Locked in darkness, These oceans remain liquid, stable, and ancient. When we look at these moons from afar, we see stillness. But beneath their shells, the oceans move. On Europa, a moon of Jupiter, the ice shell may be only a few kilometers thick in some areas, with an ocean beneath that could hold more water than all the oceans of Earth combined. That ocean rests in permanent twilight, warmed by gravitational tides, enriched by minerals rising from the deep sea floor. No sunlight reaches it, and yet, that does not mean it is empty. It simply means life, if it exists, would be life born of warmth and chemistry rather than light. On Enceladus, a small moon orbiting Saturn, the ice is cracked with long blue fissures. Through those cracks, plumes of water erupt into space, a silent fountain of ocean spray rising from below the surface. These plumes carry salt, minerals, and complex organic molecules, the same ingredients that once drifted through the infant oceans of forming planets. When spacecraft passed through these plumes, instruments detected compounds that hint at hydrothermal activity deep below. The ocean floor of Enceladus may resemble the earliest conditions of Earth, dark, warm, mineral-rich, and full of possibility. Farther still, beneath the thick nitrogen haze of Titan, lies another world, unlike any other. Titan is cold, far colder than any place on Earth. Lakes and rivers of methane flow across its surface, sculpting valleys and shorelines. Beneath its crust of ice and hydrocarbons, scientists believe there is an ocean of water mixed with ammonia, a chemistry different from Earth, but not impossible for life. Titan reminds us that life may not require the same form everywhere. It may not require oceans like ours, skies like ours, or temperatures like ours. Life may be adaptable. Life may be wider and stranger than we yet understand. These moons show us something profound. Water is not rare in the universe. It is common, hidden, waiting. It gathers where heat and gravity make room for it. It persists even in darkness. It remains even where sunlight cannot reach. The presence of water does not guarantee life, but it opens the door. It offers time, stability, and chemistry. It allows the quiet processes that began in stellar nurseries to continue in secret, sealed beneath layers of ice. When we consider the possibility of life beyond Earth, we often look to distant stars, to planets orbiting faraway suns. But some of the most likely places for life may be right here, in our own solar system, hidden beneath cold and silent surfaces that we once believed were barren. These moons are reminders that life does not always need open skies or sunlight. It may not need continents or seasons. It may thrive in darkness, warmed by the slow, patient heartbeat of a world's interior. The universe does not repeat itself exactly, but it follows patterns. Patterns of formation, patterns of heat and motion, patterns that allow oceans to exist wherever conditions remain gentle enough. And so, even here, far from the warmth of the star, the story of dust continues. Dust becomes ice. Ice becomes ocean. Ocean becomes a vessel, not for life itself, but for the possibility of it. There is no rush, no urgency, only time. And time is the universe's greatest collaborator. The oceans beneath these distant moons may have existed for billions of years. They may exist for billions more. And somewhere in their depths, chemistry may be slowly exploring itself, just as it once did in the early oceans of Earth. The cosmos is patient. It always has been. the slow drift of time across the cosmos. Now let us step even farther back, not in space this time, but in time. Time that moves so slowly that the motion of worlds seems still. Time that stretches farther than memory, farther than history, farther than any single life can measure. When we look at the universe, we see shapes. Stars, planets, moons, clouds of dust, but beneath these shapes is something deeper. Time moving softly, reshaping everything without sound. The young planetary system we have followed has settled into its quiet dance. The oceans have formed, the continents have cooled, the atmosphere has thinned into clarity. Moons circle their worlds in steady orbits. Asteroid belts remain as reminders of beginnings. Comets wait in distant reservoirs, drifting slowly through their centuries-long paths. To us, this seems permanent, but nothing in the universe is fixed forever. Everything changes, slowly, gently, continuously. Stars do not remain young. They brighten over time, their fusion deep inside becoming stronger as hydrogen is consumed. A star that once warmed a world gently will one day warm it more intensely. Oceans may evaporate, atmospheres may shift, worlds may transform again just as they once did in their infancy. Planets, too, are not static. Their crusts move, mountains rise, seas deepen, continents drift silently across the globe like slow-moving memories. What seems solid is never entirely still. Moons drift as well. Some move closer to their planets, pulled inward by gravity. Others slowly recede, inch by inch, as if reaching out into the emptiness of space. The tides they create shape coastlines, weather, even the rotation of the worlds they orbit. Over time, vast time, planetary systems rearrange themselves. Orbits shift slightly. Dust falls inward or outward. Comets melt or fragment. Asteroids collide and become smaller pieces, or gather and become larger bodies. None of this is fast. None of this is violent on the scale of cosmic time. It is simply motion, the slow breathing of the universe. If we look even farther, beyond planets and stars, we see galaxies moving through the darkness as well. Spirals rotate, clusters drift. Entire galaxies draw toward one another, shaped by gravity across distances so vast that the scale defies imagination. And yet, from our perspective, the night sky appears unchanged. Because we are small in time, we live only moments of the universe's long unfolding. To the universe, 1,000,000 years is a quiet pause. 1,000,000,000 years is a slow inhale. The story of dust, the story of worlds, is written across these immense stretches of time. It does not rush, because there is no need to rush. Time is abundant here. Time is the medium through which matter learns how to become structure, how to gather, how to form worlds and oceans, and perhaps even consciousness. When we watch the slow drift of time, we begin to understand something quiet and profound. The universe is not concerned with beginnings or endings. It simply continues, changing, shifting, unfolding. There is no urgency, no expectation, no final destination, just motion, just transformation, just the long, soft flow of existence. We are part of that flow. Our atoms once drifted through nebulae. Our elements were forged in stars. Our water arrived from the deep cold of space. Our world formed through the same patient processes that shape all worlds. Time did not hurry. It simply allowed. And the universe continues to allow for new stars, new worlds, new oceans, new possibilities, new forms of awareness. The slow drift of time is not something we must control or overcome. It is something we are carried by, gently, quietly, without effort. We are part of a story that began long before us and will continue long after. A story written in dust, in starlight, in oceans, in silence. A story without urgency. A story without end. Galaxies, the cities of stars. Let us drift now beyond individual stars and their families of planets. Let us lift ourselves away from the single system we have followed, rising farther and farther until the star grows dim, until planets become invisible, until even the faint glow of outer moons and dust disappears into darkness. Soon, we find ourselves looking not at one star, but at many. Thousands, millions, a river of light woven across the night. This is a galaxy, a vast, slowly turning city of stars. From a distance, a galaxy appears as a delicate swirl, gentle and soft, like a mist suspended in the dark, but each point of that mist is a star. And many of those stars carry worlds of their own. A galaxy is not just a collection of stars. It is billions of suns, each with its own journey, each with its own past, each perhaps with systems of planets, moons, oceans, and possibilities. The galaxy is alive with motion. Though the stars appear still, they are circling the galactic center, carried by gravitational tides as ancient as time itself. Each star moves in a slow, sweeping orbit that may take hundreds of millions of years to complete. Entire civilizations, if they arise, could rise and fall, and the star would still continue on its path, unhurried. In the heart of many galaxies lies something even more mysterious. A supermassive black hole, vast beyond comprehension. Not a monster, not a destroyer, but a quiet anchor, holding the galaxy together through the simple force of gravity. The stars orbit it not in fear, but in balance. Around these stars, dust drifts as it did in the nebula we have already seen. Dust gathers. Dust forms new worlds. The same story repeats on every scale. Galaxies are collections of stories. Some stars are young, blue, hot, bright, burning fiercely but briefly. Others are old, red, dim, slow burning, their light softened by age, and some stars have already lived and died, leaving behind the remains of their brilliance in clouds of glowing gas. These clouds are nurseries, where new stars are born from the remnants of old ones. Matter is never lost. It only changes form. The galaxy carries all its eras at once: birth, youth, maturity, and rest, all woven into the same great swirl of stars and dust. If we drift deeper into one of the galaxy's spiraling arms, we see dense clouds of gas illuminated by newborn stars. These are the stellar nurseries, the same kind of environments where our own star once formed. Here, the dust is thick, gravity is patient, and time is generous. In another region of the galaxy, we find old stars moving slowly through quieter space. Their systems are settled. Their planets, if they have them, may have cooled and aged. Some of those worlds may be barren. Some may have oceans. Some may have life that has learned how to reflect on itself, just as we do now. The galaxy is not a place of chaos, but of patterns. Grand, sweeping, repeating patterns. Dust to stars, stars to dust. Life, perhaps, somewhere in between. And beyond this galaxy, there are others. More galaxies than stars in a single galaxy. Galaxies forming clusters, clusters forming filaments, filaments forming a cosmic web. The universe is vast, yes, unimaginably so. But it is also connected, gently, through gravity and time. From the smallest grain of dust to the largest galactic structure, everything follows the same quiet principles: attraction, motion, transformation. The same story written on every scale. And we, quiet beings on a small world, are not outside this story. We are part of it. Our atoms were forged in stars. Our oceans were delivered by comets. Our consciousness is the universe reflecting upon itself, softly, in the dark. We are the cosmos, remembering. The cosmic web, the invisible skeleton of the universe. Let us drift even farther now, farther than planets, farther than stars, farther than the spiraling arms of our galaxy. We rise beyond the shape of a single star city, watching it shrink into a faint, glowing curve of starlight. And then we continue upward still. Soon, the entire galaxy becomes only one swirl among many, each one moving quietly through space, each one shaped by gravity and time. From this great distance, something remarkable begins to reveal itself. The galaxies are not scattered randomly. They are arranged in patterns, long, delicate filaments, stretching across the darkness like threads of silk. This is the cosmic web, the largest known structure in the universe. It is not made of stars alone, nor of galaxies alone. It is made of matter and gravity, woven together by the invisible presence of something unseen: dark matter. Dark matter does not shine. It does not reflect or emit light. Yet its gravity shapes everything. It is the quiet skeleton of the universe, the structure that holds galaxies in their places, guiding their slow drift through time. If we could touch the cosmic web, if our hands could reach across unimaginable distance, it would feel like nothing at all. There is no solid surface here, no walls, no pillars. And yet, the web is real. It is the framework on which the universe is built. The filaments stretch for hundreds of millions of light years, forming intricate branching structures. Where the filaments cross, clusters of galaxies gather, immense cities of stars, light, and dust. In the spaces between these threads, there are voids, regions where almost nothing exists at all, where darkness is deep and silent. The cosmic web is not static. It is slowly evolving, slowly tightening, slowly reshaping as gravity draws matter closer over billions of years. It moves too slowly for any single moment to reveal change. But across vast spans of time, the structure shifts like a whisper through eternity. To understand the cosmic web is to understand how galaxies themselves came to be. The densest regions of the web are where matter first gathered after the birth of the universe. These regions collapsed into stars and galaxies. Where the web was thinner, the universe remained quiet, open and still. The cosmic web is a map of where light could take shape. It is the quiet guide that allowed the stars to form. As we float among the great filaments, we see galaxies glowing like lanterns in the night. Their light travels for millions of years before reaching any eyes. And yet, the universe is patient. It does not hurry the arrival. It simply continues. Inside each galaxy, stars live and die. Inside those stars, atoms are forged. The same atoms that make oceans, mountains, atmospheres, and life. When stars die, they release these elements back into the galaxy, to be gathered again into new stars, new planets, new possibilities. Dust turns into light. Light fades into dust. The universe reuses every piece of itself. And the cosmic web holds all of it gently, not as a cage, but as a lattice through which the story of matter unfolds. If we reach out farther still, beyond even the web, we find that space itself continues without edge. The universe does not end with a wall or a border. It continues into a quiet and expanding openness, where time stretches and light thins. Yet even at the edges of perception, the structure remains, delicate, ancient, vast beyond language. From the smallest particle of dust to the largest cluster of galaxies, everything is connected by patterns, forces, and time. There is no moment where the story begins or ends. There is only transformation, and we are part of that transformation, not observers standing outside of it, but expressions of it. We are made of the same dust that travels through the cosmic web. We are shaped by the same time that moves galaxies in their orbits. We are the universe learning to reflect, learning to notice, learning to understand itself. In the stillness of the night, when we look upward and see the faint shimmer of starlight, we are not looking at something distant. We are looking at our own origin, our own substance, our own story. The web holds galaxies. The galaxies hold stars. The stars forge atoms. The atoms form worlds. The worlds gather oceans. The oceans cradle life. And life opens its eyes and wonders, softly, where it came from. The answer is simple and profound. You came from the universe, and the universe is still unfolding through you. The quiet birth of light itself. Let us now drift backward through time, not just millions of years or billions, but all the way back to when the universe was young, so young that there were no stars, no galaxies, no worlds. Only darkness, stretching in every direction. A darkness not empty, but full of possibility, full of matter not yet shaped, full of time waiting to unfold. In those earliest moments, the universe was warm. It was dense. It was simple. Atoms had not yet linked together. No light traveled freely. The cosmos was a quiet sea of potential, where matter and energy mingled but did not yet shine. Slowly, over hundreds of millions of years, the universe cooled. And as it cooled, hydrogen, the simplest element, began to gather. Not in one place, but in many. Gravity, gentle and tireless, began pulling these atoms into clouds, vast clouds that drifted through the early darkness. At first, the clouds were quiet. Their motion was slow, their edges soft and undefined. But gravity is patient. Over time, the clouds grew denser. The atoms pressed closer. The centers of these clouds warmed, not from fire, but from pressure, the soft squeeze of countless atoms moving inward. And then, in the stillness of the cosmic night, something happened that had never happened before. The first stars were born. There was no sound, no explosion, no sudden flare across the sky, just light, emerging slowly, steadily, spreading into the darkness. The birth of the first stars was not bright like the stars we see now. Their light traveled across a universe that was still young and thick. But gradually, the darkness began to soften. And for the first time in cosmic history, the universe carried illumination. These early stars were immense, larger than any stars that exist today. They burned fiercely, lived briefly, and ended in explosions of unimaginable brilliance. When they died, their deaths scattered new elements into the universe, elements heavier than hydrogen, elements that would someday become everything we know. Carbon, oxygen, nitrogen, iron, the building blocks of oceans, rocks, trees, air, blood. The building blocks of planets, worlds, and life. The universe had begun with simplicity. But with the birth of the first stars, complexity entered the story. Light did not merely reveal the universe, it changed it. It allowed new structures to form. It guided matter into stars and galaxies, into swirling disks and orbiting worlds. Without light, there could be no chemistry beyond the simplest forms. Without chemistry, there could be no growth. Without growth, there could be no life. Every star we see now, including the one warming our own world, is a descendant of those first stars. Their ashes seeded the universe. Their remnants formed the next generation of stars, smaller, longer-lived, more stable. These later stars formed planets. Some planets cooled into rock and ocean. Some oceans carried the slow unfolding of life. Some life eventually opened its eyes and looked back at the stars, not knowing that it was looking at its own past. Light did not appear suddenly or loudly. It arrived with patience. It took hundreds of millions of years for the first glow to fill the darkness. But when it came gently, like dawn. The universe did not rush. It did not force anything. It simply allowed matter to gather, warmth to rise, and light to form. And now, wherever we look, whether at the night sky above our world or at distant galaxies across the cosmos, we are watching echoes of that first quiet illumination. The stars are not strangers. They are our ancestors. Their light is older than worlds, older than oceans, older than life. When you look into the night sky, you are looking into a memory so vast that language becomes small in its presence. You are looking at beginnings, gentle, patient beginnings that continue unfolding even now. The universe began in darkness, but it did not remain there. It learned how to shine, and in time, it learned how to see itself shining. The journey of Stardust into living worlds. Now that the first stars have lived and died, scattering their elements into the unfolding universe, we begin to follow the story of those elements themselves. From the ashes of ancient suns, something extraordinary begins. The slow, gentle wandering of stardust through space. These atoms drift for ages, sometimes for millions of years, sometimes for billions. They move through vast clouds of gas, carried by cosmic winds, guided by gravity that whispers across unimaginable distances. They do not hurry. They do not seek anything. They simply exist, suspended in the quiet expansion of the universe. But stardust is not random. It is prepared. It has structure. It has potential. Carbon forged in the heart of a dying star. Oxygen shaped in nuclear reactions deeper than light can reach. Iron born in the last breath of a supernova. These atoms are the foundation for everything that will come. As time passes, clouds of dust and gas gather again under gravity's pull. New stars form. Around these stars, disks of dust swirl, just as we have seen. But now, the dust is richer. It carries more than hydrogen and helium. It carries the ingredients of oceans, minerals, and chemistry. From the dust, worlds will form. And among those worlds, some will become living. Let us return to one such world. Not at the moment of its violent birth, but after it has cooled and found its calm. The oceans have formed. The rain has fallen for centuries. The skies have softened into blue. The world rests beneath the light of its star, warm enough to allow transformation, steady enough to allow time. The stardust now lies dissolved in the ocean. Carbon is present in simple chains. Nitrogen forms bonds. Oxygen moves through water, easily shared between molecules. At first, there is no direction to this chemistry. Reactions happen and dissolve. Patterns appear and vanish. But time is endless here. And where time is endless, chance becomes exploration. Some molecules survive longer than others. Some begin to fold into shapes that guide reactions rather than merely endure them. These are the beginnings of molecules that remember, not memory as we know it, but pattern, structure that repeats itself. This is the first quiet hint of life. No intention, no spark, no sudden awakening, just matter finding a way to hold itself together. Over ages, these molecules learn to copy themselves. Not perfectly, but no copying is ever perfect. The tiny errors introduced in each replication become the source of variation. Variation becomes selection. Selection becomes adaptation. Still no awareness, still no thought. Just chemistry becoming organized. The ocean becomes a cradle. Not a womb of design, but of possibility, cells form. Simple at first, tiny spheres wrapped in membranes that separate inside from outside. This is the first boundary in the history of life, the moment the universe learned to contain itself. Water sustains them, minerals feed them, sunlight warms them, time guides them. And still, the universe does not rush. For billions of years, life remained simple. Single cells floating in quiet seas, dividing, merging, drifting. There is no hurry for complexity, no need to evolve quicker than time allows. The oceans are patient, and so is life. But stardust remembers. The carbon remembers the star that forged it. The oxygen remembers the blaze of fusion. The iron remembers the collapse of a dying sun. Life carries those memories within its very atoms. It is not separate from the cosmos. It is the cosmos, arranged differently, shaped into forms that can move, respond, and eventually reflect. When life grows more complex, when cells learn to work together, it does not suddenly break away from the universe. It simply becomes another expression of it. Dust became molecule. Molecule became memory. Memory became motion. Motion became awareness. And awareness, someday, becomes curiosity. The universe does not just form life. It forms life that can wonder. It forms eyes that can watch the stars. It forms minds that can ask where they came from. It forms hearts that can feel awe. We are stardust that learned how to look back at the stars. In every breath, every heartbeat, every moment of rest, the atoms within you are telling a story older than the earth itself. A story written in the quiet heat of ancient suns. A story carried across billions of years. a story unfolding still. The universe did not place you here. It grew you here, and it is not done growing yet. The silence between stars. Let us drift again, slowly rising away from the living world we have followed, away from its oceans, its clouds, its turning seasons. The blue fades into a pale curve, then into a small glowing point, and soon even that disappears against the dark. We are once more in the quiet region between stars, a place of immense distance, where space stretches in every direction, calm and unbroken. At first, this interstellar expanse seems empty, black, still, silent. But the silence here is not the silence of absence. It is the silence of depth. The distance between stars is vast beyond anything we are accustomed to imagining. Even the nearest star is so far away that light, the fastest thing in the universe, takes years to cross the space between. If we traveled at the speed of a spacecraft, it would take tens of thousands of years to arrive. And yet, this emptiness is not barren. It is the breathing space of the cosmos. Here, atoms drift freely, separated by distances unimaginable to the scales of planets. Dust particles move like whispers through an endless night. Occasionally, a cloud begins to form. The earliest hint of a new star, a faint gathering of matter guided by gravity's invisible hand. But most of the space between stars remains quiet, unhurried, unshaped. This silence is essential. Without it, stars would collide. Worlds would have no room to form. Life would have no calm in which to unfold. The silence between stars is the pause between breaths, the stillness that allows motion to have meaning, the space in which time can stretch and allow complexity to emerge. We often imagine the universe as busy, filled with explosions, collisions, bursts of energy. And in some places, it is. But most of the universe is made of quiet, not cold in a harsh sense, but calm. A serenity so deep that even thought seems to slow in its presence. The light of distant stars moves through this silence. Starlight does not rush. It travels patiently, crossing trillions of kilometers without strain. Radiance, moving through stillness, carrying with it the history of the star from which it came. If we allow ourselves to rest here, truly rest, we begin to sense something gentle beneath the quiet. A subtle awareness that the universe is not chaotic, not frantic, not violent at its core. It is spacious, it allows, it opens. In this stillness, we notice that each star has its own space, its own room to breathe, its own sphere of influence. The distances are not empty by accident. They are part of the structure. They give stability to planetary systems. They give time for life to evolve. They give silence for reflection. The space between stars is the womb of possibility. Atoms drifting here today may eventually gather into the clouds that form new stars. Some of those stars will form planets. Some of those planets will gather oceans. Some of those oceans may someday hold life that looks up at a night sky and wonders. When we look at the stars from our own world, we are not looking into foreign territory. We are looking back into the space that shaped us. Our atoms once drifted here. They floated through this darkness long before they formed the ground beneath our feet. We do not look at the stars from outside. We look at them from within. We are not observers of the universe. We are participants in it. We are made of its dust, sustained by its light, held in place by its gravity, carried through its time. The silence between stars is not empty. It is home, a home so vast we rarely recognize it, a home so old we cannot remember arriving, a home so patient it does not ask anything from us, only that we exist, gently, for a while. And in this silence, the universe waits. Not for an ending, not for a purpose. It waits because it is timeless, because it has no hurry, because everything that will ever unfold is already part of its slow, effortless motion. We are drifting now, in the same silence that existed before the first stars were born. And this silence will remain long after the last star has faded. It is not loneliness. It is peace. The shape of time on living worlds, let us return now to a world where life has taken root. Not suddenly, not dramatically, but quietly. Over ages so long that mountains have risen and eroded away in the process. The ocean that once held simple drifting cells now holds communities of microscopic life, then larger life, and slowly, ever so slowly, forms diversify. Life adapts, responds, spreads, and evolves without hurry. On a living world, time feels different. It is not measured in seconds or hours, but in seasons, cycles, and ages. The landscape itself becomes the record of time, a memory carved into valleys, layered in stone, carried in the slow flow of rivers. A mountain that seems permanent to the human eye is only passing through its own existence. Given enough time, it will soften, crumble, and become sand, carried to the ocean by streams and rivers. Given more time still, that sand will be pressed into stone beneath the sea, and the stone may rise again as new mountains. Land moves like breath, slow, continuous, barely noticeable. The same is true of oceans. They are never still. Currents shift. Tides shape coastlines. Deep waters circulate slowly around the world, carrying heat, minerals, and life. Even the sky is not fixed. Atmospheres are born from the planet below and shaped by the sunlight above. They thicken, thin, warm, cool, and sometimes transform entirely. The air we breathe today is the result of life. Life that learned how to release oxygen into the sky, slowly changing the planet over billions of years. Life and planet shape one another. Plants change the air changes the climate changes the oceans nourish the land supports life again. Nothing is separate, nothing stands alone. Everything is connected through time. The shape of time on a living world is also written in the evolution of life itself. Life does not rush toward complexity. For most of Earth's history, life was small. Simple cells drifting in the sea, the world was peaceful, slow, and quiet. Only when stability endured for long enough did complexity have the space to deepen. Creatures emerged gradually. Fins became limbs. Limbs became hands. Eyes learned to see. Minds learned to remember. But none of this happened in leaps. It unfolded like the slow opening of a flower, petal by petal, guided not by purpose, but by patience. Even now, life continues to evolve, not in sudden transformations, but in small changes passed from one generation to the next. Time shapes every living being, gently, continuously. We are never finished. We are always becoming. And consciousness, the quiet awareness that allows a being to look outward and inward, appears as simply another expression of the universe exploring itself. A way for stardust to notice stardust. a way for the cosmos to learn that it exists. On a world where life has become aware, time takes on a new meaning. Creatures remember. They tell stories. They look at the stars and sense something familiar. They feel a connection they cannot quite explain, a softness, a longing, a quiet awe. This is not imagination. It is recognition. The universe has always been looking at itself, through stars, through oceans, through clouds of dust. Now, it is looking at itself through eyes. The shape of time on a living world is layered. Geological time, mountains rising. Biological time, life evolving. Human time, thoughts unfolding. Yet all these layers are part of one continuous movement. A movement that began with dust. A movement that continues now, here, through breath and heartbeat and awareness. There is no separation between the universe and the being who wonders about it. To exist is to participate in cosmic time. To breathe is to carry history in the lungs. To think is to echo the universe back to itself. Life does not break away from the universe. Life is the universe, continuing its slow creation in a new form. And time, patient and gentle, continues to guide it, without urgency, without destination. Just being, just unfolding, just becoming. The ancient light of the cosmic background. Let us drift now beyond stars and planets, beyond galaxies and clusters, until we reach something so subtle, so soft, that it fills all of space without ever calling attention to itself. This is the cosmic microwave background, the oldest light in the universe, a faint glow that has traveled for nearly 14 billion years to reach where we are now. It is not bright. It is not sharp or radiant like starlight. It is soft, even, gentle, a warm whisper left over from the universe's earliest moments. It fills every direction, everywhere, always. When the universe was young, unimaginably young, it was dense and hot. A glowing sea of particles so tightly packed that light could not travel freely. Light scattered endlessly, bouncing and colliding, unable to escape. The universe was bright, but the brightness had no space to shine. Then, as time passed, the universe expanded. It cooled. And at a certain moment, a quiet moment, atoms formed. The universe became transparent. For the first time in cosmic history, light was free. That light has been traveling ever since, carried outward through expanding space, softened by time, stretched into longer and longer wavelengths, until it became the gentle background that surrounds us even now. This ancient light is not lost. It is not faded beyond recognition. It is simply calm, like the last warm glow after sunset, lingering long after the day has passed. If we could listen to this light, we would hear something remarkable. A memory. The cosmic background is a map of the universe as it once was, when it was still forming, still young, still simple. It shows tiny variations, tiny ripples, slight differences in temperature and density. These subtle ripples are the fingerprints of the very first structures, the places where dust and gas would one day gather into stars, galaxies, and worlds. The universe remembers everything, not with words, not with images, but with patterns. The cosmic background is the universe's most ancient memory, preserved not in stories or symbols, but in light itself. This light touches every atom in your body, every cell, every breath. You are not only made of stardust, you are illuminated by the first light the universe ever released. When we look at the sky on a clear night, we see stars. But behind those stars, behind the darkness, behind the void, there is this faint, ever-present glow, older than any galaxy, older than any world, older than time as we experience it. It is the universe as an infant, still warm, still forming, still new, and it is still here. We do not notice it with our eyes. It is too soft for that. But our instruments can see it. Our understanding can recognize it. And our quiet awareness can feel it. The ancient light of the cosmic background reminds us that the universe did not appear in an instant as we now see it. It grew. It unfolded. It allowed itself to become. The same patience that shaped stars, planets, oceans, life, and thought is written in the soft glow that surrounds all things. And just as the universe carries its earliest memory in this light, we carry our origins within us, not in the mind, but in the substance of our being. When we rest, when we breathe slowly, when we allow silence to fill us, we can almost feel it. A kind of gentle familiarity, a sense of home that spans billions of years. A recognition older than words, we are not separate from the universe. We are the continuation of it. The ancient light is the first whisper of existence. Our awareness is the latest. Both are the same story, just different chapters. The gentle expansion of the universe. Now, let us rest for a moment in the ancient light that fills all of space. Not a spotlight, not a beam, not something directed, but a soft, even warmth that surrounds everything that exists. As we float within this quiet glow, the most subtle motion of all becomes apparent. Space itself, the fabric through which galaxies drift, is slowly expanding. This expansion is not something that can be seen by the eye. It does not pull or stretch objects the way hands might pull cloth. It simply is. A quiet, steady widening of distance between galaxies, between clusters, between filaments of the cosmic web. The universe is growing, not because something pushes it, not because something forces it, but because expansion is part of its nature. When the universe was young, all matter and energy were compressed together. Not as a point, not as a speck, but as a state, dense, warm, unified. When space began to expand, it did so smoothly, evenly, everywhere at once. And it has continued ever since, without pause, without haste. Imagine exhaling slowly. Not a breath of urgency, not a gasp, not a sigh. Just a gentle release. The universe expands like that, a breath stretched across billions of years. As space expands, galaxies drift apart, yet they do not feel themselves moving. Their own gravity holds them together. Their stars continue to orbit. Their planets continue their quiet motion. Nothing inside them changes. It is only the space between them that grows. This expansion tells us something profound. There is no center, there is no edge. Every place is moving away from every other place, equally. To stand on any world, in any galaxy, and look outward is to see galaxies receding, not because they flee, but because space itself stretches. And the universe does this without effort. Expansion is not loud. It is not dramatic. It is not destructive. It is gentle. So gentle that for most of human history, we did not notice it at all. We looked at the stars and believed the universe was still, fixed, eternal. Only recently did we learn otherwise. Only recently did we realize that everything is moving, softly, steadily, like a tide that rises too slowly to see in any one moment, but changes the world completely over ages. And yet, even this is not the end of the story. The expansion is accelerating, not just continuing, but increasing in speed. Something unknown, something invisible, is guiding this acceleration. We call it dark energy, not because it is dark, but because it is mysterious. It does not shine, it does not gather, it does not resist. It simply influences space itself, encouraging it to grow. Dark energy is not a force that pushes, it is a quiet encouragement, a calm unfolding of distance. We do not yet know what dark energy is. We may not know for a very long time, and that is all right. The universe does not reveal everything at once. It allows knowledge to unfold just as it allows stars to form, planets to cool, life to awaken. Gradually, patiently, gently. What matters is not that we understand every detail, but that we listen. Because in the expansion of space, in the stretching of distance, in the drift of galaxies, there is a message. Nothing is fixed. Nothing is final. Everything continues to become. The universe is not a completed sculpture. It is a sculpture in motion. A story still being written. A breath that has not yet finished its exhale. And we are part of that breath. We are carried by it. We move with it. We unfold alongside it. The atoms of our bodies expand with space. The light we see stretches slowly as it travels. The universe expands not around us, but through us. We are inside the motion. We are included in it. We belong to it. There is no separation. The universe expands, and we expand with it, silently, softly, always. The long future of stars. Let us float now, not backward into the past, but forward, gently, into the deep future of the universe. Not the future of tomorrow or next year, or even the lifespan of a civilization, but a future so vast that time itself feels different. A future where stars live out their long lives, one by one, in quiet cycles of burning and fading. Stars are not eternal. They are born, they shine, and they eventually rest. For billions of years, a star glows by fusing hydrogen into helium at its core. This gentle burning is what gives warmth to planets, light to skies, and seasons to life. But the fuel does not last forever. Just as a candle slowly shortens, a star slowly ages. Large stars burn brightly and quickly. Their lives are brilliant but brief. Like sparks that flare and fade. They may shine for only a few million years before collapsing or exploding, returning their elements to space. Smaller stars, like the one that warms our world, burn more slowly, more patiently. They can shine for billions of years, steady and calm. These stars are gentle caretakers, offering long, stable light, the kind of light that can cradle oceans, forests, and living beings. There are even smaller stars still, tiny red stars that burn so slowly they may outlive everything else in the universe. They shine with a faint, steady glow, barely visible, but incredibly enduring. A single red dwarf can shine for trillions of years, longer than the universe has existed so far. In the deep future, when brighter stars have faded, it is these quiet, humble stars that will remain. Soft flickers of warmth in a darkened cosmos. Worlds that orbit these small stars may see climates shift slowly over impossible lengths of time. Continents may rise and fall. Oceans may freeze and thaw. Life, if it exists there, will evolve not in haste, but in rhythms slower than dreams. The universe grows quieter as time stretches on. Galaxies drift farther apart. Star formation slows. The bright, turbulent youth of the cosmos gives way to a long, gentle maturity. But even in this slow twilight, the story continues. Stars do not simply extinguish. They leave behind remnants. White dwarfs, soft, glowing embers of once bright suns. Neutron stars, dense, quiet spheres of collapsed matter. Black holes, silent anchors of gravity that patiently remain. These remnants do not shine in the same way stars once did, but they are not empty. They are memory, the universe remembering its own radiant past. Planets too will experience these changes. Some will drift away from their stars, carried by slow gravitational tides. Some will remain, orbiting ever dimmer suns under cooler skies. Others will wander the galaxy freely, silent and alone, lit only by the faint glow of starlight from afar. But in this vast, gentle future, there is no tragedy, only change. The universe does not rush, it does not cling. It allows each phase to arrive when it is time. A star shines, then rests. A planet warms, then cools. Matter gathers, then drifts. Everything moves with a rhythm too slow to hear, yet constant enough to trust. And just as stars have their lifetimes, so too does everything in the universe, including galaxies, including light, including time as we know it. But the universe does not move toward darkness with sorrow. It moves with peace. Because even when stars fade, their elements remain. Even when worlds cool, their atoms endure. Even when galaxies drift beyond view, the space between them remembers their warmth. Nothing ends. It only transforms, quietly, gently, endlessly. The future of stars is long, slow, and soft, a universe easing into rest. Just as a breath begins, fills, and eventually releases, the cosmos expands, shines, and slowly, gracefully, grows dim. Not as a loss, but as completion. The universe is not in a hurry to finish its story. It may take longer than any mind can imagine, and it will take exactly the time it needs. The quiet drift of galaxies beyond sight, let us remain in this deep future, where stars shine more softly and time moves with a long, unbroken calm. In this era, galaxies still exist, but they are no longer as near to one another as they once were. Remember, the universe has been expanding all along, gently stretching space itself. And as this expansion continues, galaxies drift apart, like lanterns slowly carried away on a vast, quiet tide. Nothing forces them outward. Nothing pushes. They simply separate because space between them grows. Their motion is effortless, unhurried, natural. In the earlier universe, galaxies interacted often. They passed near one another. Their spirals tangled. Their stars merged into new forms. Collisions and gatherings were common. But as time stretches on, space widens. The universe becomes spacious in a way that feels serene. One by one, galaxies slip beyond a boundary where their light can no longer reach us. Not because the light stops shining, but because the space it must cross continues to expand faster than the light can travel. The galaxy has not vanished. It has simply drifted beyond the horizon of visible reality. This horizon is not a wall, not a boundary drawn by any hand. It is an effect of time and distance, a gentle fading of connection. Just as sound becomes softer as one walks away, light becomes fainter as galaxies recede. Eventually, in the far future, there will come a time when most galaxies have drifted beyond sight. The night sky will still hold stars, but only the stars belonging to the galaxy in which one resides. The universe will appear quiet, small, intimate. Not because it has grown smaller, but because we will no longer see its vast expanse. The cosmos will not have ended. It will simply have become distant, still expanding, still unfolding, still present, just out of view. This is not loneliness. It is the natural rhythm of the universe, a slow, gentle separation that leaves each galaxy to exist in quiet solitude. Inside each galaxy, stars will continue to orbit. Planets will continue to turn. Moons will continue to drift through their silent arcs. Life, if it remains, will see a gentler sky. A sky with fewer galaxies shining like faint smudges of light. A sky centered around a single, familiar home. The story of the universe becomes more inward, more reflective, more quiet. Galaxies, once close enough to shape one another's paths, now drift alone through a vast, softly darkened sea of space. But nothing is lost. The same atoms still drift. The same gravity still binds. The same cosmic memory remains. We are witnessing not the disappearance of the universe, but its deepening into calm. There is beauty in this distance. A beauty that comes from knowing that everything moves according to its own timing. A beauty that understands that separation does not mean ending, only transformation. As galaxies drift beyond sight, the universe grows quieter. But in that quiet, something profound is revealed. The universe is not held together by closeness, but by shared origin. Even across immeasurable distance, all things remain connected through the simple truth that they began together. The galaxies drifting through the deep future are not strangers. They are siblings of the same first light. Their separation is peaceful. Their paths are gentle. Their motion is the slow continuation of the universe's earliest breath. Nothing is lost, only changed, softly, endlessly. The last light, the slow dimming of stars. Let us drift farther into the future now, far beyond the age of our sun, far beyond the time when most stars have finished their long, life-giving burn. The universe in this distant age is quieter than ever before. The large, brilliant stars, the ones that once lit galaxies with vivid blue-white intensity, have long since exhausted themselves. They shone quickly, lived briefly, and returned their elements back to the darkness in luminous bursts. Their light was a young universe's fire, bright, powerful, and short-lived. What remains now are the smaller stars. Stars that always glowed softly. Stars that burned their fuel slowly, patiently, with a quiet endurance. Red dwarfs, dim, steady, and gentle. have continued shining across trillions of years. But even these long-lived stars cannot last forever. Their light begins to fade, not suddenly, not violently, but gradually, like a candle reaching the last of its wax. Their surfaces cool. Their glow softens to a faint ember, and slowly, slowly, they become something new. A warm memory of a star that once was. The galaxies now hold more white dwarfs than blazing suns. White dwarfs are the glowing embers of stars, hot, dense, and small, slowly radiating away the last of their stored heat. For ages, these embers shine faintly, each one like a quiet whisper in the dark. But even their light eventually fades. After trillions upon trillions of years, they cool into something nearly invisible. Black dwarfs, silent stars that no longer shine. The universe grows dim. Not dark in a way that feels harsh or empty, but dim in a way that feels restful, like a room after a candle has been blown out, when warmth still lingers in the air. Planets continue to orbit these quiet remnants. Their surfaces may freeze, their skies may fall silent, but the atoms of those worlds remain. Nothing disappears. Everything only changes form. The universe has always known how to shift, gently, from one state to another. When the last remaining stars grow dim, the sky will no longer glitter with constellations. It will no longer hold the familiar shapes that once guided travelers, dreamers, and storytellers. Instead, the cosmos will become a vast, soft dark, punctuated by the quiet presence of black dwarfs, neutron stars, black holes, and drifting worlds without suns. Yet even here, something profound remains. The matter inside those cold remnants was forged in the hearts of ancient stars, stars that once lit oceans, worlds, and perhaps civilizations. The universe remembers its own brilliance. Its light may fade from sight, but not from origin. For in every atom, in every quiet particle, in every drifting grain of dust, there exists the memory of fire. The universe is not ending. It is exhaling. It is settling into a deep, timeless rest. A rest earned after ages of creation, motion, and transformation. Just as a day grows quiet at dusk, the cosmos settles into twilight. The last light is not a moment of sadness. It is softness. It is stillness. It is completion. The stars did not shine in vain. Their light became planets. Their elements became life. Their memory became awareness. And that awareness, the quiet knowing that you are part of this story, remains. Even in a universe of fading light, the story of everything is still present, gentle, endless, and whole. The eternal drift, matter, memory, and the universe at rest now. We arrive at the quietest era of all, an age when time has stretched so far that stars have faded, galaxies have slipped away into distance, and the universe has settled into a calm beyond anything we have words for. This is not an ending. The universe is not undone, not erased, not broken. It has simply become still. Matter remains. It does not vanish. It only changes form. The heavy elements forged in stars still drift through the darkness. Atoms that once formed planets, oceans, clouds, and living beings continue their slow journey. They travel through space that is vast, restful, and gentle. Black holes remain too. Silent anchors of gravity, scattered like deep wells across the universe. They do not roar or devour. They simply exist, holding space in their quiet way. Occasionally, drifting matter falls toward one of these black holes. Not as drama, not as destruction, but as a continuation, mass returning to the deep places of gravity, becoming part of the quiet structure of the cosmos. Even here, in this stillness, memory remains. Every atom carries the imprint of its past, forged in a star, released into space, drawn into clouds, woven into worlds, perhaps even into a living being that once looked at the night sky and wondered where it came from. The universe remembers not in words, but in presence. Matter remembers through its composition. Light remembers through its echo. Space remembers through its shape. Even as the universe rests, its story continues to exist in the fabric of what remains. Imagine a single grain of dust drifting through this quiet era. It moves slowly, without direction, without urgency. There is no star to pull it, no wind to carry it, no radiation to push it. Yet inside that grain of dust are atoms that once burned in the core of a massive star. Atoms that glowed in a supernova, were carried into space, and perhaps formed parts of countless worlds along the way. Inside that dust is the history of light. Inside that dust is the memory of oceans and mountains and skies. Inside that dust is the quiet echo of life that once breathed and wondered. The universe does not forget. It simply becomes more silent. Eventually, even black holes will release their stored mass back into space, not in an explosion, but as a slow, gentle release of particles and faint radiation. No event, no sound, no flare. Just matter returning to open space. A final exhale, and when all things have drifted into even distribution, no clusters, no structures, no centers, the universe will not be empty. It will be calm. A still ocean of the smallest particles, spread evenly across an endless space, without hurry, without change, without need. This is not darkness. It is rest. The universe began in motion, a burst of expansion, a rush of formation, a dance of stars and worlds. But all motions eventually soften, all rhythms eventually slow, all stories eventually sleep. In this final quiet state, there is no loss, no ending, no absence. Only a peace so deep that nothing needs to become anything more. The universe rests, and in that rest, its whole history remains woven through every particle. From the first light to the last ember, from dust to worlds to dust again, from silence into presence and back into silence. The universe has completed a full breath, and it is enough. So now we drift, not forward, not backward, just resting where we are, carried by the same quiet stillness that holds galaxies, stars, and dust. The story of the universe continues, not in sudden moments, but in long, gentle movements of time. You are part of that movement, not separate, not observing from the outside, but inside it, made of the same elements that have traveled through stars and silence. Feel the breath move softly. No need to deepen it, no need to change it. Just noticing it, like noticing the soft glow of starlight in the distance. The body becomes heavy, like a planet settling into orbit, held effortlessly. The thoughts slow, like galaxies drifting, each one moving farther away, quietly, without urgency. There is nothing to do here, nothing to solve, nothing to hold, just rest. The same rest that exists between the stars. The same rest that fills the universe when light has traveled as far as it can and simply continues without effort. The universe does not hurry, and neither do you. You may let go now. Gently, comfortably. Let the mind float like dust in calm space. Light, unbound, safe. If sleep comes, it comes naturally, like night following day, like stars forming from dust, like galaxies unfolding from gravity's slow embrace. There is room for you here, room to breathe, room to be, soft, quiet, unhurried. We drift now together into stillness, and the universe drifts with us.